In previous videos, we've used TNT to process a variety of data files in order to get tree output that varies different parameters, such as the inclusion or exclusion of DNA, or the inclusion or exclusion of living taxa and morphology. And you can consult those videos. I'm going to use those, however, as a starting point for today's session, which is all about extracting the tree files from TNT output. It doesn't have to be TNT, but that's what we're going to focus on for now. So just as a starting point, here is the batch file that I used to create a small number of output files, and the key lines that I want to share with you now is one of them that I've highlighted here. So UA, that refers to Upham Asher. Upham is a DNA dataset, Asher is a morphology dataset, and the full on the other side of that underscore indicates that it's based on the combined full dataset, the DNA plus morphology. I also deleted the fossils using only extant taxa, and then excluded the morphology, including only DNA. And in the previous video, I showed you how to use commands like tax code minus to exclude certain groups of taxa, to use the command cc, and then this sort of right square bracket to exclude a certain morphology partition. So you have to look at the previous videos to look at that a little more in detail. But for now, all I want to do is draw your attention to these out files, right? This is the output of what TNT is writing. So if I switch now to those out files, let's start with this UA full dot out, which is this thing right here. You'll notice that it's a Nexus formatted tree block. So it labels each one of these trees. These are all the optimal trees that TNT recovered for the data set that I gave it, plus it adds a strict consensus. And again, that's explained in a previous video that I'll link in the comments to this video. Now what I'd like to do is show you this really simple R script that lets you go into a folder with text files like what I just showed you and extract say, for example, the strict consensus of all those that TNT wrote, and then write them into a data frame that you can then analyze, and you can make figures of trees. You can do all sorts of things with it. Here are some of the basic steps. So in R, I've defined, you have to tell R something about what those file names look like. So in this case, my TNT dataset always has the suffix .out. Could be anything, but that's the one I chose. So that's what I'm going to call. I'm going to give it a variable called suffix. I'm using RStudio here. I hit Control Return, and now it's got that suffix as one of its variables. I also need to write a variable. In this case, it's going to be another file that's going to contain each of the strict consensus trees from these various text files that I'm going to read in. So I'm calling that tree strict. And then I'm going to give it a file name, and this will be written later, and as you'll see in the for loop that's coming up. So I just do the same thing, Control Return, and then tree strict is also defined. And now I need to make this into a Nexus file for reasons that I hope will become clear. And so that includes putting a little Nexus command at the top. And this is just an R command write paste. That's all I'm doing is making a text file, right? So I'm going to do Control Return, and that's written these things here. Nexus, then begin tree separated by a line return. What does that file look like? Well, here it is in this file, treestrict.tree. I right click, just look at it with any old plain text editor like Notepad++, and there it is. It's just a text file with Nexus and then begin trees on a new line, which is exactly what I told it to write in that line right there. Now R needs to know a little bit more about the file names, because the key data that defines each of those strict consensus trees that I want to extract are contained within each file name, and that's where this variable z comes in handy. So I use a command called list files in R, and all I'm going to do is put the file names into that z variable. So I hit Control Return, and then you can see I'll just show you what's in that variable now. Those are all the file names. Yeah. And so in this file, I have a strict consensus that is relevant to or that resulted from the analysis with the Upham-Asher data set using only extant taxa and using only DNA. In this one, I used the data, I used Upham-Asher again, but in this case, I used all the data morphology plus DNA, and I didn't exclude the fossils, and so on. So the next step here is this for loop, and that's going to go through each one of these, in this case, very short list of file names. Of course, this kind of exercise is designed for cases in which you might have many dozens or hundreds or thousands of file names that you need to go through systematically. And it's going to extract not only the strict consensus from each one of these files, but it's also going to extract the parts of the file name that's going to remind you the parameters of each one of those data files. So let me show you what I mean by that. And I want to unpack this for loop in order to do that. So the for loop is based on this variable z. And in particular, it's based on the length of z. So remember, z is just the list of file names, right? There they are again. If I take the length of that list, what I've highlighted there, and I hit Control Return, it gives me a value of 5 because there are 5 file names in the list. So I want a for loop that's going to go through each one of those file names, in this case from 1 to 5, and I want to extract certain things out of each file name. So I don't actually want to run the whole loop just yet. So I'm just going to arbitrarily say, let's say I is 1 for the moment. Right, so there's my I equals 1 because I just told it that, and you can recover that first file name just by calling it z bracket I and bracket, and there it is, Upham-Asher extant DNA dot out. So I want to take that and put it in another variable called file name. So that's what I do here on line 11 in my little R script, and you can see that file name Upham-Asher extant DNA is right there. And it basically took the suffix that I defined before, dot out, and removed it from the file name. It used a gsub command, and what I want to find is the variable suffix. What I want to replace it with is between these quotes, which in this case is nothing. It's going to delete the suffix, and what you end up with, instead of ua underscore extant DNA dot out, you just end up with what's in the file name, which is ua underscore extant DNA. Okay, so I'm still slowly making my way to define the parameters under which I get a strict consensus within this particular tree file, ua underscore extant DNA dot out. And the study that generated the data by which I generated that strict consensus is, I'm going to put in this variable here called study. And all this is going to do is take, using regular expressions, I'm going to take everything that's before the underscore and put it in variable study. So you can see for yourselves what that's going to do. It's going to take the capital U, capital A. So if I execute that line number 12, there it is. I got study, and it put UA into my variable study. And data just does the same thing, but it takes, using regular expressions, that underscore and places any text or numbers after the underscore into this variable data. That's a typo. I've modified this script so it should say data. So that's just, it's helpful to, any text you add after a number sign means R doesn't do anything with it. That's just for you to remember what each line means. Okay, so let's define that data variable. There it is. So it's taken the text after the underscore, put it in this variable data. Now comes the tricky part. The next 2 lines in this for loop are finding the strict consensus tree that TNT has written to each one of those files and putting it into the variable, well, ultimately into this variable strict. But first of all, you have to come to grips with the fact that there's going to be a different number, potentially a different number of trees in every single output file that TNT writes. And let me show you what I mean by that. If we go to our TNT output files, such the Z bracket I end bracket file when I equals 1 is this one right here. And here we only have the one optimal tree and the export minus command. Remember, that's a TNT command, not an R command. That was explained in a previous video. That writes the strict consensus to the very end of the tree file, and that's what I've highlighted here. A different TNT output file could have a lot more optimal trees, such as this one I'm showing here. And again, the consistency is that the strict consensus is the very last one. So it's labeled here tree TNT 35, and that's the strict consensus. So how do you get this particular strict consensus out of all these all these various tree files? Well, you have to count the number of lines in the text file, and I use that with a combination of length and count fields. So let's see what that command gives us then. And I'm just going to execute this bit that's highlighted here, and I come up with a value of 9. And that simply means that once I go into the Z bracket 1 TNT output file, that's this one right here, extant dna.out, I double click on it, and you can see that there are 9 lines in that file. I have to, however, skip the first 6 in order to get to that strict consensus file. So that's why I take 9 and then I subtract 3. And that is the number that's going to go into line strict. So let's execute that line right there, line strict. And it's just going to take what you've already seen. It's going to take the length count fields of that text file, subtract 3. In this first case, that's going to give us 6. And sure enough, the value of line strict when we execute that command is 6. Okay. This next command is going to put into this variable strict the text that starts in or that starts after these number of lines that we've skipped, which is the value of line strict. And it's going to use this command read table. So read table, if you want to learn about any of these commands in particular, all you have to do is type question mark, then read.table, and then you'll get in the help viewer, a detailed description of what each part of that command can do. For now, all you have to know is that you need a file name here, which is still that right there. So Z bracket I is this first element in our list of file names. So it's going to read that. It's going to skip the number of lines in line strict, which is 6. And then it's going to read into the variable strict just one row. And it's going to read it as a table, which is slightly different. So let me just show you what happens. Then I'm going to hit Control Return, put into strict what ends up being a data frame in R. So if I click on that data frame, what I see here is the variable that I want, and it's going to arbitrarily be put into this column V1, and then just an empty column V2. All I really want here is V1. And so now I can write that column, strict $V1, into the text file that I have that I defined up here, treestrict.tree. So let's do that. And I'm going to use in R these write paste commands. And that's it. So let's have a look then at what it's written to my variable treestrict, which is, like I said, writing to this file treestrict.tree. I'm going to go back to my R folder, and here's what I've just written. I'm going to edit it with Notepad++, and here it is. It's written to a file that is using the elements of the file name. That's the data that went into it up in Asher. It is sampling just the extant taxa, and it's sampling just the DNA. And here's the strict consensus for that tree. Of course, I'm not finished yet because this isn't a completed Nexus file. So at the very end of that, I have another write command that's going to add these elements as well. It's going to add an end colon to the end of the file, and that's all I need. So I'm just going to execute that, and then I'm going to go back to my my Notepad++ file. Yes, it's been modified, so I want to see what it did, and all it did was add added the end semicolon. Okay, so let's actually use the for loop now, because remember, all we did was sort of cheat by defining I as 1 and going through each one of these lines individually. So what I'm going to do is I'm going to just erase everything in my set of variables here. I'm going to delete the trees strict file. So we'll just start from scratch. And then I'm going to redefine all these variables. I'm going to redefine suffix. I'm going to redefine trees strict. I'm going to each one of these lines, hitting Control Return, and then I'm going to define my nexus file with the right paste on line 5. I'm going to tell R what the Z is, right? Just to remind everybody, that just lists the file names. And remember, you could have hundreds or thousands of these files, and this for loop will go through all of them. And now I'm really going to use the for loop and create my tree strict. Okay, so Control Return. It runs the for loop, and then I need to put a little end at the end of the nexus file. And now let's have a look at our trees strict. There it is. It wrote a new one. Edit with Notepad++. Yes, reload it. And it now has one line containing the strict consensus for each one of those different files, right? And remember, the Z was defined as anything that ends in this variable suffix, which was this thing here, this out. And just to show you where those are, if I organize it by type, it's these 5 files. And what can we do with this file now? Well, we can load it right back into R and have a look at these trees. So this line I'm now going to execute with this command read nexus. And you'll see that we now have a data frame X, which when I click on it, shows you the names of the various topologies. And if I want to plot any of them, I can use a command like, well, let me just type this out so you see what I mean. I'll get rid of the ladderize for now. If I just want to type the first tree and only the topology, I use a square bracket, and I'll just use the number 1, hit Control Return, and here it is. That, you can see, shows you that tree file. I could do a few things there. I can reduce the font size, CEX equals, say, 0.7, and then it's still not very good. If you want to get rid of these big margins around the edges, you can add a comma, no margin equals true, and then it makes it a little bigger. So then you can maybe increase the font size to 0.9. You know, it's a little better. Maybe a somewhat more intuitive way to plot trees in R is you get the data frame, which I've called X, thanks to the read nexus command. And then instead of a double square bracket and then a number corresponding to 1 through 5, the number of trees in that data frame, I can just use a $sign, and it's just very much like any other data frame, and it'll give me the option of which one of those strict consensus names I want to use. So let's use that one that let's use the full one. And you can see that is a much busier file than, there are more taxa in it, a lot of fossils. Those are the ones that I arbitrarily gave taxon names starting with ZZ. And it's a much less well-resolved topology. You can also use, I think I can do this, ladderize within the plot command, making sure to close or add the right number of parentheses, and that makes it slightly more legible. Of course, I probably want to decrease the font size a little bit to back to 0.7. There you go. So that is how you can extract strict consensus trees out of TNT output files.